Hello everyone, this is your first recorded lesson, and this week we're going to be learning about Pythagoras' theorem. So when we're learning about it, there's a few things you have to know. You have to know what the hypotenuse of a right angled triangle is and how to identify it. You need to be able to know how to label the sides A, B and C. You need to know about this formula here, c squared is a squared plus b squared, to calculate the hypotenuse of a right angled triangle and also to calculate a shorter side. So these are the various things you need to be able to do this week. So first of all, what we're going to learn about is what is the hypotenuse of a right angled triangle and how do you identify it. So the hypotenuse is the longest side of a right angled triangle. So it's always longer than the other two and it is always across from the right angle. So in the diagram you can see here, the one that I've marked in red, it's clearly the longest side. And if you can see the right angle, a little square in the corner here, it is pointing towards the longest side. So there's two ways of identifying the hypotenuse. It's the longest one and it's across from the right angle. This triangle, just the other way around, the red one is again the hypotenuse, longest and across from the right angle. Here, turned the other way around, this right angled triangle, but again, longest side and across from the right angle is the hypotenuse. So you can pause the video and identify the hypotenuse of each triangle. So you're just picking one of the letters A, B or C. So pause that, see if you can work out the answer to those. And once you're ready, move on. So the first one, the hypotenuse is C, D, G, L, M, and R. If you struggle to do that at all, just let me know, post a message on Teams. Now, if we know the length of the two shorter sides of a right angled triangle, we can use the formula that's below there to calculate the length of the hypotenuse. So this is called Pythagorean theorem or Pythagoras' formula, anything like that, basically involving the word Pythagoras. So c squared equals a squared plus b squared. Now, most of the time, but not always, we label up the triangles A, B, and C, where C is the hypotenuse. We're going to call the longest side C. The other two are sides A and B. It doesn't really matter which way around you call those. So in this particular triangle, C is the hypotenuse. It's across from the right angle. So therefore, c squared is equal to a squared plus b squared. Now, you don't have to learn how that works exactly, as in where that comes from, but I'll post a video that you can watch if you're particularly interested in that. It's a maths antics video. It gets mentioned later on in the slides. So we usually call it C. It doesn't have to be A, B, and C, but that's generally what we use most of the time. So you'll need to go into your assignment to find the link for the maths antics video if you want to find out where this comes from, this Pythagorean theorem. Okay, so that's the second lesson today. If you're still watching from lesson one, you can stop if you want and then come back to this the next day, or you can continue and just watch all the way through, doing all the daily practice and all the questions, etc. So first of all, we've learned how to identify the hypotenuse of a right angled triangle. And we've seen how to label the sides A, B, and C. Remember, C is going to be the hypotenuse, it's the longest side. So we've done the first two things. So if you can do those, you're happy with those, you're ready to move on to actually using the formula. So in lesson two, I'm going to start you off by doing some daily practice, solving each of the equations in order to find out the value of A, B, C, D, etc. Okay, I've put an example over the side here. So 3m plus 2 equals 17. You're going to subtract 2 from both sides first, giving you 3m is 15. Dividing by 3 gives you m is equal to 5. You can check your answer by thinking if m is 5, 3 5s are 15, add 2 does indeed make 17. So for each of these, you're going to have to subtract or add to both sides first, and then divide both sides to find out the value of a, b, c, etc. In question 5, you're going to have to subtract from both sides, but you've got the letter E on both sides. You're going to have to subtract to begin with 2e from here. You're going to have to subtract 2e from here. So hopefully you can remember that from the lessons in class. So you pause your video, have a go at those, and then the answers are on the next page. Take some time to go through and check to see you've got those correct. If you have any issues with that, post on Teams. So how do we actually use Pythagorean theorem, the formula? C squared equals A squared plus B squared. Well, first of all, you have to label up the sides A, B, and C. C is the hypotenuse, it is across from the right angle. So as you can see here, I've labelled up this side C. The other two, A and B, doesn't really matter which way around they go. So what you do is you start off by writing the formula. C squared equals A squared plus B squared. You look at your diagram and we can see what the values of A and B are. A is 3 and B is 7. So over here, we can say that C squared is 3 squared plus 7 squared. Now remember, squaring, it does not mean times by 2, it means times by itself. 3 squared is 3 times 3. So I've just spotted a wee mistake here, which I'll just quickly fix. It should say just 9. So 3 squared is 9, 7 squared is 49. You add them together and you get 58. Now that is what C squared is equal to. I only want to know what the length of C is, not what C squared is. So if you recall, the opposite of squaring is square rooting. So if we take the square root of 58, you get 7.6. Now that has been rounded to 1 decimal place. Just watch out your rounding when you're doing this. So just a quick recap. You put your numbers 3 and 7 into the formula. You work out what 3 squared is. You work out what 7 squared is. You add them up and you take the square root. Notice that once I've taken the square root, it just says C now, not C squared anymore. So C is equal to the square root of 58. Next example. We've got another right angle triangle. The hypotenuse is C, so I've labelled that one with a C. The other two, A and B, doesn't matter which way round. I'll substitute the numbers into the formula. I've worked out that 5 squared is 25, 8 squared is 64. I've added these numbers together. I've taken the square root and I've rounded correctly to 1 decimal place, so 9.4. So now it's your go. I want you to calculate the hypotenuse of each triangle. If you need to go back with a video to check the formula and how to use it, then by all means do that. Basically, I've filled it in, well, I've left some blanks for you to fill in, and all you need to do is complete the blanks and work out the answer to each one. And I'll get the answers in just a minute as well. So pause the video, copy this into your jotters, and then work out the answer. Pause the video, work out your answer. Pause the video, work out your answer. Now you can check your answer with mine, make sure you've got it correct. Okay, so again, you can stop there. If you want to do lesson 3 just now, then that's absolutely fine. Lesson 3 is not on the slides here. You need to go back to the assignment, and there is an attachment telling you lesson 3's work. So for lesson 4, what we've done so far is we've identified the hypotenuse of a right angle triangle. We've labelled the sides A, B, and C, and we've used the formula to calculate the hypotenuse of a right angle triangle. And I've got a wee typo there. So once you have done those things and you've practiced by looking at the exercise which I posted in lesson 3, I'll also post the solutions to that so you can look those up and just check you got those correct. Again, if you have any issues, just please let me know by posting in Teams. And the next thing we're going to do is use the formula to calculate a shorter side. So rather than the hypotenuse, you're going to calculate the shorter side of a right angle triangle. Your daily practice, first of all, is to work out what mistake Sue has made. So she's shown all her working out in red on the left-hand side there. Look through her working out, see where she's gone wrong. If you pause the video, see if you can figure it out. Answers on the next page. Sue didn't square the numbers correctly. She multiplied by 2 instead of squaring, which gave her the wrong answer. She should have done 10 squared is 100 plus 6 squared is 36. Added those up, taken the square roots and worked out our answer that way. So we've already worked out the hypotenuse. So now to work out the length of a shorter side, we start off in the same way. So in this example, we've got the hypotenuse is 7, it's across from the right angle, it's the longest side. And we've got the other two sides we can call A and B. So I've labelled up A as 5 and I've left B as the blank side. So in the next slide, you're going to see how to actually complete it and figure out the length of side B. So it's a little bit different from the working out before, but not drastically different. So as you can see, I've substituted in the value for C, which is 7, into the formula over here. I've substituted in the value for A, which is 5, and that goes in here. Now, I could just as easily have called the bottom side A and this side B, in which case you just sub them in the other way around. But that's what I've chosen to do this time. So I've worked out what 7 squared is, I've worked out what 5 squared is. But what you'll notice here is I've got 25 plus B squared, and what I want to work out is B. So I need to get rid of this 25 from both sides, so I can just work out B. So I'm subtracting 25 from both sides. So when I subtract 25 from the right-hand side, what you'll see is that that cancels out, because 25 take away 25, and that just disappears. So you get 49 take away 25 is 24. You're going to take the square root of 24 and round it to one decimal place, and you get 4.9. So the difference is from previously, you're subtracting something from both sides before you take the square root. In this example, again, label them A, B, and C, where C is the hypotenuse, and that is 13.1. I'm going to substitute those numbers into the formula. So C is 13.1, A, we don't know what that is here, and B is 12.5. So using your calculator to work out what 13.1 squared is and 12.5 squared is, and you end up with this. Now, I want to work out what A is rather than A squared. So first of all, I've got to take away this 156.25 from both sides. And when I do that, that disappears from there. So you do 171.61, take away 156.25, and that gives me what A squared is equal to. Take the square root and round it to one decimal place. So A is 3.9 centimeters. Are you going to try this time? Again, you need to pause the video for each one, copy out the working out, fill in the blanks, and then check at the end, see if you've got them correct or not. Okay, and here are the answers. So pause the video again for each one, check you've got them correct. Let me know if you have any problems with that. And lesson 5, go back to the assignment and just complete the attached PDF with some practice questions. Again, I'll post the solutions for those.